One day, your brain will run out of power, the neurons will go quiet, and from where you're sitting, everything will just stop. End of story, right? Maybe, or maybe that's just one run of a pattern the universe can, in principle, play more than once. In this video, we're going to strip the mysticism out of death and ask a brutal scientific question. If you are just a 20-watt computation running on 13.8 billion-year-old stardust, does physics lock you into a single playthrough, or is death more like hitting reset on a cosmic game that might, somewhere, someday, load you back in? But before we continue, please subscribe to the channel to give your support. Let's continue. Here's the hard claim. You don't have a mind, you run a mind. You are not a solid thing on the inside. You are a process that started, is running right now, and will stop. And if death is any kind of reset button, it has to act on that process, not on some hidden extra object. Inside your skull, the entire thing runs on about 20 watts of power. That's the same power as a small light bulb or a basic phone charger. At that low power level, your brain is handling everything: vision, language, movement, planning, your sense of I. The hardware is around 86 billion neurons, packed into about 1.3 to 1.4 kilograms of tissue, roughly 3 pounds. Each neuron can connect to up to 10,000 others, so you end up with around 100 trillion to 1,000 trillion synapses. That's a 1 with 14 to 15 zeros, firing all day, every day. Those signals don't move at sci-fi speeds. An action potential in a neuron travels at roughly 1 to 120 meters per second. That's around 3 to 400 feet per second, so slower than a car on a highway, much slower than electricity and copper. But the trick is the massive parallelism. Millions of neurons spike at almost the same time in millisecond windows. That huge synchronized switching is what lets a 20-watt warm, wet system outperform any current supercomputer at things like pattern recognition and real-time control of a body. So when you say me, what are you actually pointing at? Are you pointing at the carbon, hydrogen, oxygen, nitrogen making up the cells? Because those atoms cycle in and out of your body over years. Are you pointing at the individual neurons, which grow, shrink, die, and get replaced? Or are you really talking about the ongoing pattern of activity, the way this network is firing, updating, and rewiring itself every split second? That pattern is a computation. Inputs come in through your senses, the internal state changes, outputs go to your muscles and back out into the world. It is physical, it is local, and it is changing all the time. This is the first key idea. Your identity is not stored in one special spot. There is no single you neuron to point at. Your identity is spread out over patterns of firing and patterns of connection strength across that entire network. Memory lives in which synapses are stronger or weaker. Habits live in which pathways are easier to activate. Personality lives in long-term biases in how circuits respond. If those patterns change slowly, you feel like the same person growing and aging. If they change abruptly from injury or disease, you feel like you aren't yourself. Now here's the uncomfortable question. If the important thing is the pattern, not the individual atoms, then in principle, can that pattern be paused and later restarted? You already know that the brain can pause consciousness. Sleep is the soft version. General anesthesia is the hard version. Under full anesthesia, activity in the cortex shifts into very simple, repetitive patterns, low-frequency waves. The high-complexity, high-frequency activity that lines up with conscious experience almost disappears. Patients report a very specific kind of nothing. Not boredom, not waiting, just a clean gap. You hear, "We're starting now." Then you wake up and it feels like no time passed. From your perspective, that's a jump. Conscious, then nothing, then conscious again, with zero internal sense of how long the gap was. You could be out for 20 minutes or 4 hours. Your brain doesn't write anything to memory during that time. Coma is a longer, harsher version. In many comas, brain activity is severely reduced for days, weeks, even months, and yet some people come back to full or near full consciousness. When they describe it, they don't talk about feeling trapped for weeks. They usually describe the same hard cut: last memory, then suddenly waking up in a hospital. So you already have proof that the process that feels like you can be shut down and later resume, as long as the underlying structure stays mostly intact. From outside, doctors see a long timeline of events, machines, scans, interventions. From inside, there is a discontinuity, a clean break, then a new frame of experience. In a very loose way, that already behaves like a low-level reset. Not a new life, but a new segment of the same process, after a gap that you never experience. The obvious next question is there anything else hiding in the system, something that leaves when you die and comes back when you wake up? This is where standard physics is very direct. Our best framework for matter and forces is the Standard Model plus general relativity. It lists all the particles and interactions we have strong evidence for: electrons, quarks, photons, gluons, W and Z bosons, the Higgs field, and gravity acting on energy and mass. There's no extra term in those equations labeled soul, no special particle that behaves differently inside brains. Neurons use standard physics. They depend on ion channels, electric fields across membranes, diffusion of neurotransmitters, receptor binding. All of that can be written in the language of electromagnetism, quantum mechanics, and thermodynamics. If consciousness appears in that system, it has to be because of how those known pieces are arranged and how they evolve in time, not because an extra invisible ingredient jumps in. So any reset, if it exists, has to be something that these physical laws can support. No shortcuts, no exemptions. That gives you a strict boundary. This run of your mind, the one producing this exact moment of experience, depends on one specific brain, with one specific wiring diagram and chemical state. When blood flow stops, when oxygen and glucose fail, the process degrades, cells die, connections break, proteins denature, the local computation winds down and stops. For this specific brain, in this specific body, that's the end. There's no known physical mechanism that suddenly lifts you out and carries you somewhere else. So if we're going to talk about a reset, it cannot be about the survival of this particular lump of tissue. But there is a different angle. If your mind is a physical computation and computations are just physical processes obeying rules, then nothing in physics says a given pattern can only ever run once. You can run the same software on two different computers at two different times and get the same behavior. You can, in principle, rebuild the same circuit twice if the information that defines your brain state, the details of all those synapses and activity patterns, is part of the physical universe. Then there is no deep law that says the universe cannot ever reinstantiate a state that is very, very close to your current one. That doesn't mean it will happen, it just means the door isn't locked by default. Local death is definitely a full stop for this implementation of you. But on very large scales, across huge stretches of space and time, or inside advanced simulations, or in future technologies, there might be other places where a pattern close enough to you runs again. From that new point of view, it would just feel like waking up after a gap you don't remember, just like anesthesia, only stretched over cosmic distances. So the seed of the whole idea is this: death ends this specific run of your mind. But physics, as far as we currently understand it, does not strictly forbid other runs of a similar pattern somewhere else. And that's the opening that people mean when they talk about death as a possible reset. However, there is a huge force pushing in the opposite direction, a deep one-way trend in the universe that wants to erase structure and scatter information. If any reset is going to happen, it has to push against that trend, the trend we call entropy. And that raises the next question. In a universe where everything tends to fall apart, can any pattern, including you, really come back? If death is a reset, it has to work against the strongest trend in the universe, entropy, the built-in push from order to disorder, from structure to chaos. And you feel that trend that's time only ever moving one way. On the level of single particles, the basic laws of physics mostly don't care which way you run them. If you filmed two atoms bouncing off each other and then play the video backwards, the motion would still look legal. The equations for how they move work almost the same forwards and backwards in time. That symmetry is baked into a lot of fundamental physics. But when you zoom out to big systems like a glass of water, a planet, or a brain, you never see that kind of clean reversal. Ice melts, it doesn't unmelt. Smoke spreads out, it doesn't all gather back into the corner of the room. This is where entropy comes in. Entropy is just a way of counting how many microscopic arrangements match the same big picture. There are many more ways for molecules to be scattered and messy than to be neatly arranged and structured. So as time goes on, systems slide into those more typical messy states. Your memory is a direct side effect of that trend. You remember yesterday's breakfast because it left ordered traces in your brain. Specific patterns of connections and protein changes were written into neurons. That is a low entropy record, a structured imprint. You don't remember tomorrow's breakfast, not because the future is magical, but because no record of it has been laid down yet. The universe doesn't give you access to future data. It only gives you records of lower entropy states in your past. That's what we call the arrow of time. So here's the pressure point. If time has this one-way arrow built in through entropy, and your mind is just one more physical process inside that arrow, how could any reset possibly work when your brain is already an entropy machine? At body temperature, about 37 degrees Celsius, roughly 98.6 degrees Fahrenheit, your neurons are constantly burning glucose and oxygen. They pump charged ions in and out. They reset their internal voltage. They release and recycle neurotransmitters. Every one of those steps takes a clean, ordered energy source and spits out heat and waste. Your brain is only about 2% of your body weight, but it eats around 20% of your resting energy. That's a huge, constant flow of fuel being turned into electrical spikes and then dumped as heat into your surroundings. Every thought you have, each decision, each memory update, is supported by little shifts in the positions of billions of molecules. Ion channels opening and closing, vesicles releasing chemical packets, receptors changing shape. Small local bits of order in your head are paid for by increasing disorder outside your head. Your skull leaks heat into the air. Your body dumps waste into the environment. That's the cost of keeping the pattern of you running for one more second. Death is exactly what it looks like when that fight is lost. When circulation stops and cells no longer get fuel, the brain can't hold its carefully maintained gradients anymore. The difference in ion concentrations across membranes collapses. Proteins misfold. Membranes break down. The very specific low entropy pattern that encoded your identity and memories breaks apart into thermodynamic noise. The system stops resisting entropy and just slides downhill. If entropy is always pushing downhill, does that mean the only way to get a reset is to somehow rewind the entire universe back to a previous state, frame by frame, like running a video backwards? That sounds like the obvious picture, but it's not how physics works. A rewind in the strict sense would mean reversing every microscopic interaction, every molecule, every tiny collision in the exact opposite order. It's not just unlikely, it's so insanely fine-tuned that you can treat it as impossible for any real system. The number of specific details you'd have to line up is beyond comprehension. But a reset is not the same thing as a rewind. A reset doesn't require the universe to march backwards. It only requires that some region of matter and energy, somewhere, is arranged again into a configuration that can run the same computation your brain ran. That's a huge difference. You don't need the spilled milk to climb back into the glass. You just need another glass of milk poured the same way. Entropy makes that kind of recreation rare by accident, because random shuffling of matter almost never produces highly ordered states. But entropy does not write a rule that says forbidden. In principle, you can push matter uphill into lower entropy configurations by spending energy and dumping even more entropy somewhere else. That's exactly what life does and what machines do all the time. So the real obstacle to a reset is not a cosmic law that says no takebacks. It's the sheer practical unlikeliness of the right arrangement happening again. Unless there is some process, natural or artificial, that is actively steering matter back into those special patterns. And to understand how hard that is, you have to look at the numbers on the biggest scale we know, the scale of the universe itself. The observable universe is about 8.8 times 10 to the power of 26 meters across, roughly 93 billion light years from one side to the other. Inside that volume, you have on the order of 100 billion galaxies, each with hundreds of billions of stars, gas, dust, dark matter, and enormous black holes sitting in the centers. When you ask where the entropy is, most of it is not in the gas or the stars. It's mostly dominated by those black holes. A single supermassive black hole, like the kind in the center of a big galaxy, can have an entropy around 10 to the power of 90. That is a 1 with 90 zeros. The entropy of your entire body or your entire planet is microscopic in comparison. Your brain's reset in terms of entropy cost is a rounding error in this cosmic budget. The universe absolutely has enough room in its entropy accounting, so to speak, to pay for recreating a low entropy system like your brain many, many times over. So the real question flips. It's not, is there enough entropy allowance to reset me? It becomes, is there any mechanism anywhere that actually drives matter back into that specific low entropy pattern again? The universe is huge, but size and energy alone don't guarantee that your exact pattern or a close cousin will ever show up again unless something pushes it that way. If entropy drives time in one direction and death is the local collapse of your pattern in that direction, is there any wiggle room left at all? Can your specific structure ever appear again, or does time's arrow lock you into a single one-shot run forever? Here is the key point. Entropy gives you a one-way arrow for events. The glass shatters, the star burns its fuel, the brain ages and fails. But entropy does not outlaw the reappearance of patterns. It just makes spontaneous repetition incredibly rare. If the universe, or a larger multiverse, is big enough in space or in time, and if its laws allow the same configurations of matter to arise more than once, then there is some non-zero chance that a brain state close enough to yours will happen again. And if consciousness really is tied only to the pattern and the process, then from the inside of that new configuration, the experience that wakes up there would feel like you continuing after a gap you can't remember. That's the tension. Physics gives you a strong one-way push toward disorder, and yet it doesn't completely slam the door on repeated structures. So now you have to ask a sharper question. If the rules don't guarantee that you get only one run, and they also don't guarantee you get a second, what does the universe actually do with the matter that used to be you? How does it recycle it? And does that recycling ever get anywhere near recreating the kinds of patterns a mind needs? Every atom in your body has already gone through its own cycle of birth and death, many times over, long before you were here. Matter has been resetting itself for 13.8 billion years. The question is whether that kind of reset ever reaches the level of a whole mind. The universe is about 13.8 billion years old. For the first few minutes after the Big Bang, it was too hot and dense for atoms at all, just a plasma of fundamental particles. Only after it expanded and cooled for a few 100,000 years did protons and electrons finally slow down enough to combine into neutral hydrogen, the simplest atom. That hydrogen, which formed around 380,000 years after the Big Bang, is still with us, and some of it is in you. The hydrogen in your water, in your fats, in your DNA, has lineages that go all the way back to that early universe phase. The heavier elements in your body, the ones your brain really leans on, did not come from that first stage. Carbon, nitrogen, oxygen, calcium, iron, those were built later, inside stars. Stars fuse hydrogen into helium, then helium into heavier nuclei, layer by layer, up to elements like carbon and oxygen in their cores. When massive stars die, they explode as supernovae. That explosion spreads those elements into space. Some even heavier elements form in the explosion itself, in seconds, under extreme pressure and temperature. So the carbon in your neurons, the calcium that helps your synapses fire, the iron in your blood, all of that came out of stars that lived and died billions of years ago. So at the most basic level, you are already made from recycled debris. Atoms are not loyal to any particular body. They are reused over cosmic timescales with zero concern for personal identity. And that leads to a sharp point. If your atoms keep changing, but you still feel like the same person, then whatever you is, it cannot just be this specific set of atoms. That means identity cannot be about which carbon atom sits in which neuron at which moment, because those atoms come and go, and yet your memory of childhood, your language skills, your habits survive. That pushes you back to the pattern view. The you we care about is in the arrangement and activity of those atoms, not in their serial numbers.
It's in the exact wiring diagram of your brain, the strengths of your synapses, the way networks activate and inhibit each other over milliseconds. Your long-term memories are stored in changes to connection strengths, in structural changes in dendrites and synapses. Your habits are encoded in which pathways are easier to trigger. Your personality is in broad but stable biases in how systems respond to inputs. All of that is information, written into matter at fine resolution. Death doesn't just move atoms around, it destroys that fine structure. When the brain breaks down, you don't just lose this batch of carbon, you lose the particular microscopic arrangement that made those atoms act as your mind.
So the universe is already very good at recycling matter and energy. That part is standard physics, no mysticism needed. Atoms fall apart and recombine. Stars live and die, planets form and erode, life forms eat and are eaten. Your body is a node in that flow. The reset of matter is normal. The reset of a particular information pattern is what's hard. A true reset, in the sense of you coming back, would require not just grabbing some of the same atoms, but reconstructing an information pattern that is close enough to your original brain state that it runs the same kind of conscious process. To do that, you would need absurdly detailed control, positions, connections, maybe even quantum states at very small scales. We are talking nanometers and below, and timing at milliseconds or less. Not just a rough copy, but a very specific structure. This is where the difficulty jumps. Moving atoms around is cheap for the universe. It does that constantly. Restoring a particular high-information arrangement is expensive. You are asking for the universe or some future technology to rebuild a very specific, extremely detailed pattern out of chaotic inputs. That is not impossible in principle, but it is a much tighter requirement than matter is conserved. So the picture so far is this. Your atoms are ancient and recycled. Your present body is temporary. Your sense of continuity comes from a pattern of information in your brain. Death scatters the matter and destroys that pattern locally. Matter will absolutely reset. You, as a process, only reset if that information pattern is somehow recreated, which means the real question is not about atoms, it is about information. And that raises the next problem. If the reset is really about information, what exactly has to be restored for you to count as back from zero? And how does physics even keep track of that level of detail in the first place? If death is a reset, something has to be put back. Not your atoms, not your heartbeat, but the detailed state that made your experience what it was. In physics, that thing has a very specific name: information. At the deepest level we know, everything physical can be described by a quantum state. That state is not a little picture of reality. It's a rulebook for what you'd see if you made every possible measurement. It tells you which outcomes are likely, which are rare, and which are impossible. It is a compressed description of all the physical possibilities of a system at that moment. Your brain is no exception to this. The chemistry inside your neurons, the shape of electron clouds around atoms, the way ions move through channels in the membrane, all of that has a quantum description. You don't need to bring in mystical quantum consciousness to connect this. You just accept that the sodium, potassium, calcium, and other ions that move in and out of neurons are quantum objects. They're allowed energy levels, they're binding to proteins, the way they tunnel or move through channels. All of that is controlled by quantum rules. When you scale up, you can get away with talking about voltages and concentrations, but underneath those voltages is a quantum state that encodes what those particles are doing. So the information that makes up your state right now is not just which neurons are firing or which synapses are strong. It ultimately sits on top of the quantum state of a gigantic number of particles. The universe keeps track of that state through its laws. It does not just hand-wave it away. And this is where the idea of information becomes concrete. Changing that state has a real physical cost. Landauer's principle nails this down. It says that erasing one bit of information in a physical system has a minimum energy cost. You have to dump a tiny, specific amount of heat into the environment for every bit you irreversibly wipe. That cost depends on temperature. At around 310 Kelvin, which is your body temperature, the energy per bit is extremely small. But your brain is not flipping just one bit. It is pounding through something like 10 to the power of 14 to 10 to the power of 15 basic operations every second. Huge numbers of effective bits being updated, reset, and overwritten. That means your experience is riding on massive information flow and constant entropy production. Every time a neuron fires and then resets, every time an ion gradient is restored, information is being erased and rewritten, and heat is being dumped into your surroundings. Your thoughts are literally tied to physical information processing. There is no clean separation between mental and physical here. One is implemented by the other. So if information has a physical cost to erase, you can flip the question. If you wanted to reset you, what information would you have to restore? And how detailed would that reset have to be for it to count as the same mind continuing? Think of your brain as a gigantic, messy, but real state machine. At any instant, there is a physical state that includes things like which neurons are firing, what their voltages are, how much calcium is in each synaptic terminal, which receptors are activated, what hormones are in the bloodstream, and also how all of that is changing over very short times. If in principle, you could write down all of that at nanometer resolution in space and at millisecond or better resolution in time, you would have an insanely detailed specification of what your brain is doing over a short window. Right now, we're nowhere near being able to measure that. And even if we could, the data volume would be ridiculous. But physics does not prohibit the existence of that description. The universe runs it automatically as the system evolves. A strict reset would mean creating another physical system whose relevant state matches that description closely enough that it evolves in the same way. Same inputs, same internal rules, same outputs. That is the scary part. If you really want a reset that is more than a rough imitation, you are asking for a specific, ultra-high resolution state to be rebuilt. And yet, there's a twist. Quantum mechanics does not let you casually duplicate unknown states. You do not get two perfect copies of you for free. The no-cloning theorem says that there is no general machine that takes an arbitrary unknown quantum state and spits out two copies of it. If you already know everything about the state, you can prepare as many as you like, but you cannot feed an unknown state in and just photocopy it. This is not an engineering limitation. It is a mathematical result of how quantum amplitudes behave. So if you dreamed of a reset where the universe makes a perfect clone of your current exact quantum configuration, keeps the original, and now you have two indistinguishable yous, that scenario is blocked at the most fundamental level. What this forces is a more subtle picture. Any cosmological reset cannot work by simple, perfect quantum copying of your specific brain. Instead, it has to be about recreating the right structure and the right statistics, building a system that has the same functional pattern, the same kind of information structure without violating quantum rules. You do not get a trivial fork. You get, at best, a new system that matches the original to within some tolerance. Now add another heavy constraint, black holes and the information paradox. Black holes have entropy, and that entropy scales with the area of the event horizon, not the volume. That suggests the number of possible internal states of a black hole is huge, and it also suggests that the information about what fell in is not simply destroyed. When Stephen Hawking first calculated black hole radiation, it looked thermal and random, as if information about what went in was lost forever. That clashed with the idea that the laws of physics are reversible at the deepest level. Decades of work pushed the field toward one conclusion. Information is not truly lost, even in black holes. It gets scrambled, spread out, and coded in subtle correlations in the outgoing radiation and in the structure of space-time. The details are still being fought over, but the trend is clear. The universe seems to conserve information globally, even when locally it looks hopelessly destroyed. Apply that to you. The total information that once specified your brain and body gets blasted apart when you die. At the local level, your state stops, your structure decays. But if the underlying laws of physics are information conserving, then in some highly distributed, scrambled way, the information that you existed in this configuration is still part of the global state of the universe. Not in a nice readable file with your name on it, but also not erased from reality. So, a reset, seen through this lens, is about reassembly. You would need to grab enough of that information, not necessarily the same physical atoms, but the same pattern of correlations, and drive it back into a running physical process that has the right structure to host your kind of consciousness. It has to be a process, not a static snapshot, because experience is about evolution in time. That reassembled process could, in principle, exist in many places. It could be in this universe, far in the future, built by an advanced civilization. It could be in a new universe born after this one ends, if cosmology allows cycles. It could be in another branch of reality, if many worlds is the right way to think about quantum mechanics. From your first-person point of view, the details of where it runs are hidden. You only ever know, I am conscious with this memory and this state right now. So you get a very loaded conclusion. If the universe really keeps information and if patterns define minds, then death looks like local deletion of your process plus global scrambling of your information. A true reset would be one of the rare situations where enough of that information is gathered and re-implemented in a new physical system that runs you again. The laws do not rule it out, but they make it very constrained. And that leads to a harder question. If you need that kind of detailed pattern to run, how often does the universe actually repeat patterns like that? And does the size of reality make another run of you basically guaranteed? If the universe doesn't reset you, maybe a bigger structure does, the multiverse. Not with kindness, just with brute force repetition of patterns, including the pattern that feels like you. Start local. Your observable universe is just the region from which light has had time to reach you since the Big Bang. That region has a radius of about 4.4 times 10 to the 26 meters, around 46 billion light years, even though the universe is only 13.8 billion years old. Space has been stretching while light has been traveling. Outside that bubble, there can be more space, maybe a little more, maybe an absurd amount more. Inflationary models, the ones where the early universe expanded faster than light for a short time, point strongly toward the larger universe being vastly bigger than the patch you see, and it might even be infinite. If space really is infinite, and if matter is roughly uniformly spread at large scales, you end up with a nasty little conclusion. There are only so many ways you can arrange a finite chunk of matter. Once you use up all distinct possibilities inside some huge but finite volume, patterns have to repeat, the same way a truly infinite string of random digits will eventually contain your phone number, your birthday, and every book ever written, not once, but infinitely times. The same logic hits physical configurations. This is basically Max Tegmark's Level 1 multiverse. You don't add new laws of physics, you just accept that beyond the horizon, there are other regions with the same physics, and their matter is arranged in every way that is compatible with those laws. Somewhere out there, unimaginably far away, there's a region where a planet formed extremely similar to Earth. Same mass, same orbit, same chemistry, and on that planet, biology unfolded in almost the same way, leading to a person with almost your exact genome, growing up in almost your exact environment. The distances involved are stupidly large. Estimates for an exact duplicate of your observable universe can land around 10 to the power of 29 meters or more. That's a 1 followed by 100 billion zeros. But if space is really infinite, stupidly large is not the same as never. The probability per volume is tiny, but the amount of volume is unbounded, so the expected number of copies is infinite. So, somewhere in this inflating level 1 picture, there are regions with a you reading or watching this same line with the same memories up to this moment. From the outside, that sounds like a cosmic copy-paste. But here's the key problem. Does that distant copy actually count as your reset? From a third-person view, it's easy. The you here and the you there are just two different individuals, two separate world lines. They will diverge from this moment on. One coughs halfway through the sentence, the other doesn't. One pauses the video, the other lets it run. There is no communication between them, no physical interaction, no shared future. They're just extremely similar systems running in parallel. From a first-person view, it's less obvious. You never experience being both. You experience exactly one stream of consciousness, one sequence of moments, and you never feel yourself jumping from one copy to another across that vast distance, unless there is some continuous or reinstantiated process that bridges them. To you, they are separate stories you'll never read. Some philosophers say if consciousness is only about the pattern, then any exact reinstantiation of that pattern is literally you waking up again, no matter where it is. Others say that without a physical or causal link, it's just someone else with your memories, and calling that your reset is just word games. That's level 1, just more space. Now add a deeper layer, level 3, the many worlds interpretation of quantum mechanics. Here, you don't just get repetition in different locations, you get branching in time. Every quantum event that has multiple possible outcomes actually realizes all of them, but in different branches of reality. There is no single history, there is a whole branching tree. Apply that to you. Every fraction of a second, the universe branches into many versions. In some branches, you look away from the screen. In others, you keep staring. In some, you change your mind about something important next week. In others, you don't. That creates a branching forest of yous, all sharing the same past up to a point, then diverging. Each branch has its own continuous stream of consciousness, tied to its own physical brain state. In this picture, when you die in one branch, that branch just doesn't contain further yous. The process stops there. But there are other branches where your body avoided that accident, got the treatment in time, or just randomly didn't get the disease yet. Those branches keep going. As long as there is at least one branch where your brain stays working, there's some version of you still running. Not all branches are equally important though. The wave function assigns amplitudes to different outcomes, and those amplitudes translate into probabilities when you make measurements. Branches with higher amplitude have more weight in the total structure. This is where a controversial idea comes in. Some people argue that your subjective expectation should be biased toward branches where you keep existing because you can never be aware in branches where you're already dead. This gets called quantum immortality, and it's heavily criticized because it leans on fuzzy reasoning about measure and self-location. Even if you throw that idea out, branching still effectively acts like a constant soft reset of your life path. There isn't one future, there is a cloud of possible futures, all realized. You just move along one of them. Your identity is not a single line, it's a bundle of nearby lines that share most of their early structure and then separate, and the measure, the weight of those lines, matters for how likely each version is. Put level 1 and level 3 together, and you get something very stark. If space is infinite, and if branching is real, then reinstantiations of you, or near copies of you, are not just possible, they are statistically forced. In that combined multiverse, there are countless branches, and countless regions where your exact initial pattern forms and evolves. That means that in a raw counting sense, there are versions of you waking up over and over again in different places and different branches. But does that actually give you a reset? Or is it just a multiverse full of people who happen to share your starting conditions? This is the key ambiguity. From the outside, it is a swarm of similar but distinct individuals, each with their own mind and their own world. From the inside, your only handle on any of this is one stream of experience with one set of memories. Right now, there is no tagging your consciousness that says, you are instance number 2.3 times 10 to the 42 of this pattern. You just are. So the multiverse ramps up the stakes. It says if reality is big enough, then patterns like you are not rare. They are scattered everywhere in state space and physical space. Some people take that as a kind of guarantee of reset. Others say it changes nothing about your odds in this specific run. You still die, your local process still stops, and all the other copies are just that, other copies. If you want to treat death as a reset in this picture, you have to make a choice about identity. Do you tie you strictly to this one continuous line in one region, or do you allow that any exact or near exact rerun of the pattern anywhere in the multiverse counts as you waking up again? Physics doesn't give you that answer. It just tells you the structure of possibilities. And there's a further twist. All of this assumes the universe, or multiverse, just expands and branches forever. But there are other models, more extreme ones, where the entire cosmos doesn't just keep rolling forward, it actually cycles. Big bangs, big crunches, or more exotic resets built into space-time itself. If brute force repetition across space and branches isn't enough, you can ask a harsher question. What if the universe itself has a global reset button, one that wipes everything and starts again, and in that new round, your pattern appears once more? Some cosmological models don't just allow resets in a vague, philosophical way. They literally build a reset button into the life cycle of the universe itself. Not for you personally, but for everything: space, time, matter, all of it. Right now, your best working model of the universe is called lambda CDM, written as the Greek letter lambda plus cold dark matter. In plain language, that means a universe filled with normal matter, plus a lot of invisible dark matter, and a cosmological constant, a kind of energy built into empty space. When you plug those ingredients into Einstein's equations, you get a universe that expands and, because of dark energy, expands faster and faster over time. In that picture, there is no global reset. There is a long, slow drift toward heat death, where everything is cold, dilute, and quiet. But lambda CDM is not the only game in town. You can write other models that still obey general relativity but have different behavior. Some of those alternatives are cyclic. Instead of one big bang and then endless cooling, you get a sequence: big bang, expansion, slowing down, contraction, crunch, and then maybe another bang. That's a built-in reset, at least on the scale of entire universes. So you have to ask, if the cosmos itself runs in cycles, where do patterns like you fit inside that loop? Take the big crunch idea first. In that scenario, expansion doesn't keep speeding up forever. It eventually slows, stops, and reverses. Gravity wins. Galaxies that are currently flying apart would start to fall toward each other. Space would shrink, densities and temperatures would rise. Over huge timescales, everything gets squeezed into a smaller and smaller volume. Conditions go from cold and sparse back to hot and dense. The Big Bounce is a variation on that. Instead of the universe collapsing into a final singular point where the equations break, the story says that when things get extreme enough, quantum gravity effects kick in and turn the collapse into a rebound. The universe bounces. The contraction phase transitions into a new expansion phase. You get another Big Bang moment, but it is connected to the previous cycle, not pulled out of nowhere. In this kind of model, you don't have one universe. You have an endless chain of them. Each cycle gives you new hot, dense beginnings, new stars, new planets, new chances for complex structures to form. Roger Penrose pushes an even stranger version, called conformal cyclic cosmology, CCC for short. Here, you don't have a simple crunch then bang. You have a universe like lambda CDM that expands forever, but Penrose points out a mathematical trick. If the universe expands so much that all matter decays, black holes evaporate by Hawking radiation, and only very low energy radiation is left, then particles no longer have a meaningful mass or size scale. In that limit, the difference between extremely large and extremely small starts to lose meaning. You can rescale the stretched out cold universe and reinterpret it as the hot, dense state of a new Big Bang. In CCC, each eon is a full universe from its Big Bang to its cold, stretched future. When that future is empty enough, you mathematically squash it and treat it as the start of the next eon. Black holes are important here. They swallow matter and information, but then they slowly evaporate, leaking it back out as faint radiation over absurd timescales. In Penrose's picture, the pattern of that radiation, after everything has decayed, influences the initial conditions of the next cycle. So here's the sharp question. In any of these cyclic models, does anything like a detailed pattern of a brain survive from one cycle to the next? The obvious answer is no. Galaxies get torn apart or burned out. Atoms are smashed or stretched. Ordinary structures like stars, planets, and brains do not ride through the crunch or the conformal rescaling intact. They're gone. Their matter and energy is redistributed into a much simpler state. But on the information side, the story is less clean. If fundamental physics really conserves information, then even when everything you recognize is destroyed, the information about those past structures might be encoded in subtle correlations, in the radiation field, in the quantum state of the vacuum, or in boundary conditions at the transition between cycles. That information would be deeply scrambled and spread out, not readable in any simple way, but not literally wiped out. If that is true, then in an ultra-rare patch of some future cycle, the initial quantum fluctuations, the tiny regularities and density that seed new galaxies, could, by pure chance plus these inherited correlations, line up in a way that leads to a universe where, billions of years later, a planet almost like Earth forms and a brain pattern almost like yours appears. Run forward long enough and you get an extremely low probability but non-zero chance that some cycle somewhere in this eternal sequence generates a configuration that matches your original mind closely enough to count as the same computation. Do we have evidence for this? People have actually checked the sky for hints. One place to look is the cosmic microwave background, the afterglow of the Big Bang. CCC predicts certain circular features or patterns in that radiation that might be fingerprints of the previous eon. Some groups have claimed to see such things, others have pushed back, reanalyzing the data and saying the patterns are just statistical noise. As of now, the mainstream view is that simple lambda CDM still fits the observations best, with no clear need for cyclic add-ons. So, cyclic cosmologies sit in a weird zone. They're speculative. They involve heavy math and extrapolation far beyond what we can directly test. But they're not just fantasy. They're serious attempts to extend general relativity and quantum field theory into regimes where the standard model of cosmology might break down. They're allowed by the equations, we just don't know yet if the real universe actually uses them. If, however, the universe really does cycle forever, the logic from earlier comes back in a more intense way. Every new cycle is another shot at producing every allowed pattern of matter and information, including the one that was your brain. Run that for an infinite number of cycles, and the chance of your pattern appearing again, somewhere, in some eon, is not just non-zero, it becomes statistically guaranteed. Each time it appears, from the inside, that run of the pattern would feel like a new first-person wake-up. So, cyclic models crank the reset idea up from maybe in a distant region of this universe to maybe in a completely new universe built on the ashes of ours. But they also highlight a deeper point. They treat your life as one segment in a much bigger structure, a segment with a beginning and an end in time, which raises the next question. What if even without cycles, you never actually vanish from the grand picture? Not because you live forever, but because your entire history is a fixed piece of space-time, laid out from beginning to end, and once it exists, it's always there. Relativity is the first hit to your normal picture of time. In special relativity, there is no universal now that everyone in the universe can agree on. Different observers moving at different speeds slice space-time into past, present, and future in different ways. Two events that you call simultaneous might be one before the other for someone flying past you at a high velocity, and both descriptions are valid according to the math. That already kills the idea of one global clock ticking the same way for everyone. Think about what that means. The labels past, present, and future are partly about your motion, your frame of reference. For one observer, your death might be in the future. For another, moving differently, it might already be in their past. Both observers are seeing the same space-time, just slicing it differently. If the categories shift like that, then the deep thing underneath is not the flow, it's the structure. That's where the block universe picture comes in. Instead of treating the universe as a movie playing frame by frame, you treat it as the whole film reel at once. Space-time is a four-dimensional object, 3 dimensions of space plus 1 of time. Every event is just a coordinate in that object. The moment you were born, your first day at school, your worst fight, your best decision, and your death. All of those events are different points in the same four-dimensional structure. Your experience of time feeling like it flows, like you move from one moment to the next, is then just what it feels like to be a process running along one particular line through that block. In relativity, we call that your world line. It's the path you trace out in space-time. Your life is not being written as you go. In this view, it's already encoded start to finish, like a data file that already contains the opening and the credits, and you only ever see the frames in order. Once history is fixed, your world line has a definite length in time, measured by the clock that moves with you. That own time is called proper time. From your birth to your death, that proper time might be, say, 80 years, roughly 2.5 billion seconds. In space terms, you stay within a small band around Earth, a few times 10,000 kilometers across. In time, you span those 70 to 90 years. That chunk is the physical process that was you. And in the block picture, that chunk doesn't vanish when you die. It just sits there as part of the geometry. From some external mathematical perspective, nothing ever blinks out. The event of your death is just one end of the line. The events of your earlier life are still in the block. The 10-year-old you, the 20-year-old you, all of those versions are fixed points in space-time. If you draw the map, they are there, permanently. The fact that your conscious process can't go back and re-inhabit them doesn't change that they are part of the structure. So then, in this framework, what would a reset even mean? You can't rewind your existing world line, because that would literally mean changing the block itself, and relativity doesn't give you tools for that. What you can imagine instead is a second world line, somewhere else in space-time, that has almost the same shape as yours. Same kind of body, same kind of brain, same sequence of key events, maybe even the same memories up to some point. It's like the universe embedding a rerun of your life pattern in a different region of the four-dimensional map. That second world line doesn't have to be in the future in any deep sense. It could be far away in space but overlapping in coordinate time, or it could be in a later cosmic cycle, or in a different branch in a multiverse picture. From the block universe point of view, they're just two similar curves in the same or related space-time. The interesting question is no longer, does time allow a reset? It's, how often does the universe actually contain near duplicate world lines? Relativity then starts to look like a very soft, very cold form of immortality. You never get to jump back to your earlier self, you never get to change what happened, but the earlier versions of you never disappear from the 4D map. They are not gone, they are just not accessible from the later points on your world line. The child you, the teenager you, the you watching this right now, in this view, all exist as different coordinates on that line. Forever. Once the block is there, it's there. That doesn't give you comfort in the normal sense, because your subjective experience marches one way along the line and then stops. But it does change the story. Your existence is not a spark that appears and then vanishes into nothing. It's more like a solid segment embedded in the structure of the universe. You are part of the permanent record of space-time. Now, combine this with the earlier reset ideas. If space-time, or some bigger multiverse version of it, contains multiple copies of your life pattern in different regions, cycles, or branches, the block universe doesn't choose between them. It just stacks them all into the structure. They are all there as separate world lines. The idea of a reset then turns into a question about which world line your next moment of experience lands on, if any. From the first-person point of view, dying on one world line and waking up on another, structurally similar one, would simply feel like losing time and then continuing, exactly like anesthesia or coma with a bigger gap. The block picture doesn't tell you whether that handover happens. It only tells you that if there is another similar world line, it is just another path in the geometry. The jump, if it exists, is about how consciousness attaches to these paths, not about space-time itself. So then the tension ramps up. Physics can describe your life as a fixed object in a four-dimensional landscape. It can allow other very similar objects to exist elsewhere in that landscape, and it can tell you that your earlier selves never really disappear from the map. None of that tells you where the process stops from the inside. For that, you have to zoom back down from space-time as a whole to the actual machinery in your head that generates the stream of moments, and you have to watch what happens to that machinery when it finally fails. To talk about any reset, you have to look straight at the shutdown sequence, the exact chain of events where the process that feels like you stops running and does not come back by itself. When blood flow to the brain drops below a critical level, neurons very quickly lose their supply of oxygen and glucose, the two main fuels that keep their ion pumps working. Within about 10 to 20 seconds, voltages across their membranes start to fail. Large areas of cortex stop firing in organized patterns. You lose consciousness. On an EEG, the busy, complex waveform collapses into low-amplitude, slow activity. If circulation is restored quickly enough, some tissue can repolarize and recover. If not, the damage locks in, and the structure that encoded your memories and identity starts to physically break. Around this borderline, things get strange. Some recordings show a surge of high-frequency, synchronized activity in the moments after blood flow stops, before the brain goes flat. At the same time, many people who come back from the edge report near-death experiences. Tunnels, bright regions, strong feelings of peace, rapid life review sequences, or encounters with beings or deceased relatives. The straightforward, non-mystical interpretation is that these are the brain's last internally generated narratives, produced as networks go unstable and feedback loops fire in unusual ways. The timing matters. These experiences, when they happen, occur while there is still some organized activity, while the brain is in crisis but not yet structurally destroyed. Once the spreading depolarization has passed and tissue has stayed without oxygen for long enough, the system does not generate any more coherent patterns. Whatever stories you had in those last moments are still part of the running process. They are not after death, they are before the process fully halts. Medical language separates clinical death from the actual cellular breakdown. Clinical death is when there's no heartbeat and no breathing. From the outside, the person looks dead. But at the cell level, many structures are still alive. Different tissues tolerate lack of blood flow for different times. Some skin and connective tissues can hang on for hours. Some brain regions are more vulnerable and die in minutes. This gap is what lets CPR and defibrillation work. Resuscitation is basically a race to restore circulation and oxygen before irreversible damage spreads too far. So when someone comes back after a cardiac arrest, what actually happened is that the global conditions dropped below the threshold for organized consciousness, then were pulled back up before the microarchitecture was too badly damaged. Enough synapses, dendrites, and cell bodies were still intact that the pattern could restart. Memory and identity were not fully erased, just temporarily put out of operation. That is a pause and resume, not a true reset. The point of no return is not the exact second the heart stops. It is when the structural damage crosses a certain threshold. Once synaptic structures start degrading in large numbers, once proteins unfold and clump, once membranes rupture and cells swell and burst, the detailed connectivity pattern is gone. The exact arrangement of synaptic strengths, dendritic spines, receptor distributions, and microcircuit layouts is what encodes long-term memory and personality traits. When that is physically destroyed, there is nothing left for blood flow to wake up. After that, even if you could magically restart the heart and lungs, you would not get the same mind back. You might not get no consciousness at all, or in partial cases, you might get severe brain damage with lost memories, changed personality, or locked-in states, because the hardware that used to run you no longer exists in the same form. The computation is not just paused, it has lost its instructions and its wiring. From that moment on, any meaningful reset of you cannot come from this particular brain. This pile of tissue is done as a carrier of your pattern. The atoms will be reused, the molecules will break down and enter other systems, but the high-resolution information that defined your mind is gone at this location. If you are ever going to exist again as a thinking process with the same memories and character, that has to happen in some other substrate, another brain, an artificial system, or something even stranger. So death, as medicine measures it and as physics describes it at the biological scale, is a permanent stop of the local computation. Once that shutdown crosses the structural threshold, there is no natural way for this process to restart from here. And importantly, there is no sign of any extra field or particle escaping with your identity as the tissue fails. Everything we see is consistent with a physical process ending because its machinery is destroyed. If a reset still exists in any serious sense, it has to be implemented by something outside the biology. The universe would need other mechanisms on much bigger scales or deeper levels that can pick up the lost pattern and run it again. That points you back to the things we just walked through: information conservation, multiverse statistics, cyclic cosmologies, and it also opens a more direct and unsettling possibility. Maybe you get a reset not because reality is kind by default, but because reality itself is some kind of computation, and someone, somewhere, can literally reload you like a program. If the universe is a simulation, then to reset you, the simulator doesn't need magic, it needs data. Specifically, a detailed snapshot of your brain state, plus enough of your surrounding environment for that state to be coherent. They need the wiring diagram of your neurons, the strengths of synapses, the ongoing activity, hormones and neurotransmitter levels, and what's happening around you so your perceptions make sense when you wake up. That's a huge data set, but it's not infinite. Your brain has on the order of 10 to the power of 14 to 10 to the power of 15 synapses. If you store just a few bits of information per synapse, plus some overhead for neuron states and supporting cells, you get something like a few hundred terabytes to maybe exabytes worth of information to specify one detailed snapshot. Those are insane numbers by current human standards, but not insane for a civilization playing with planet-sized or star-sized computers. A computer shell spread around a star, a few 100 million kilometers across, could in principle host mind-boggling amounts of storage and processing. So from the simulator side, a U-save file is expensive but doable. They can compress, they can store differences instead of full states, they can store generic environments and just patch in your specific brain. The exact engineering doesn't matter here. The main point is that physics doesn't forbid building hardware on that scale, and a civilization at, say, a Type 2 Kardashev level would have star-level power to burn. Once you can store and evolve these states at will, reset becomes trivial for them. They can roll back the entire simulated universe to an earlier time, which from inside would look like the whole cosmos jumping back to a previous configuration, and nobody remembering the overwritten timeline. They can also just roll back your local region or even just your brain and splice that into a new environment, like loading your character into a new level. They can fork your consciousness into multiple branches. Take one saved brain state and let it run in many different scenarios at once, each branch experiencing itself as the real, continuous one. They can pause you, stop the simulation at the moment of your death, store your state, and then resume you a trillion years of external time later on totally different hardware, with no subjective delay for you. You'd feel, I blacked out, now I'm awake in a different place, while outside, an absurd amount of time passed. From your point of view, hitting reset in this setup is exactly like waking up from anesthesia. One instant of experience, then a gap you don't feel, then another instant. You never see the pause or the copying or the edits. Your continuity is just last memory before death, followed by first memory after reset. The arc in between is entirely outside your awareness. So, do we see any signs this is happening? People have looked for crude pixels in reality, like hints that space or energy comes in bigger chunks than we expect. They've looked at high-energy cosmic rays for signs of a grid underlying spacetime, or weird regularities in physical constants that might be coding shortcuts. So far, everything we measure fits standard physics very well. No obvious glitches, no low-resolution edges, no clear signature of being inside a program. But that doesn't get you off the hook. A perfect or even just very careful simulation is not going to leave obvious fingerprints. If the simulators know their physics, they can implement it exactly at the level we can probe. You wouldn't expect to catch them using blocky graphics and bad random number generators. The whole point is that the simulation is good enough to fool any agent living inside it. And even if we are simulated, we're still stuck with physics because the simulators have to instantiate something that behaves like our physics in order for our experiments to come out the way they do. If they get relativity or quantum mechanics wrong, we'd notice. So whatever deeper hardware exists has to implement evolution rules that match our observations, down to insane precision. The reset button they have is not magic. It's a function of a bigger computational system obeying its own physical rules. So the simulation hypothesis gives you the cleanest reset story. Death of the simulated brain is just a program halting. A reset is just reloading a stored state and letting it run again. The scary part is that this does not require the universe to be kind, just curious or indifferent, and it does not require your consent. Your only input to the question, will there be a next run, is whether some outside intelligence decides you're worth reloading, which raises a sharper angle. Even if the universe itself never resets you, could some civilization inside it, with enough time and power, decide to resurrect you on purpose, not as a side effect of a simulation, but as a project? If someone out there can harvest entire galaxies, resurrecting the dead stops being a miracle and becomes an engineering problem, a question of energy, hardware, and priorities, not ghosts. Start with the Kardashev scale. It's a rough way to rank civilizations by how much power they can control. Type 1 is planetary. You can use about 10 to the power of 16 to 10 to the power of 17 watts, basically all the energy that hits your planet from its star, plus what you can get from internal sources like geothermal. That's full control of weather, oceans, and global power systems. Type 2 is stellar, around 10 to the power of 26 watts. You're capturing a significant fraction of your star's entire output, using huge structures like swarms of satellites, often called Dyson swarms. Type 3 is galactic, around 10 to the power of 36 watts. Now you're tapping the output of most stars in a galaxy. Humanity right now is not even type 1. We sit around 0.7 on that scale. We use about 10 to the power of 13 watts globally. We are far below planetary control. So when you think about resurrection via technology, you're talking about civilizations that are as far beyond us as we are beyond bacteria. The gap is that big. Next, look at what they could do with that power if they turned matter into computation. This is where the idea of computonium comes in. Computonium is just a label for matter that's been redesigned to be as efficient as possible at computing. No wasted structure, no unnecessary mass, every atom arranged to store and process information near physical limits. A small asteroid of computonium, say about 10 to the power of 12 kilograms, about a billion tons, could in theory perform absurd numbers of operations per second, way beyond all current human computers combined. Now scale that to a Type 2 civilization. If you can build structures around the star, a whole Dyson swarm of computing nodes, each node made of highly optimized material, you can get hardware that makes our best data centers look like toys. We're talking about planet-sized or star-encircling computers, with enough capacity to simulate planets, civilizations, and individual minds in huge detail, not as a stunt, but as just one of many things you do with your energy budget. With that kind of hardware, digital resurrection becomes a serious engineering concept, not guaranteed, but on the table. If you know enough about the current state of the universe, in principle, you can work backwards, like solving a massive inverse problem. Gravity, radiation, particle distributions all carry faint traces of what happened before. The laws of physics run forward, but the patterns they leave can be used to infer past configurations. A civilization with ridiculous sensors and extreme computing power could try to reconstruct historically plausible versions of ancient brains, including yours. They wouldn't recover the exact quantum state, that's gone, but they might reconstruct a detailed model that matches all the macroscopic evidence: DNA traces, recorded history, environmental data, maybe even tiny residues in artifacts and rocks. They'd aim to rebuild a brain state that, when run, produces memories and behavior consistent with the person you were. From inside that reconstruction, if it's good enough, you'd remember your life, your relationships, your death, and then waking up in some kind of future environment. You'd insist you are you, because your internal memory chain is continuous. Those memories would be the product of a reconstruction algorithm, but your experience would still be real. Your feeling of continuity would be exactly what you have now, just extended. Some thinkers push it further into ideas like Frank Tipler's omega point. That only makes sense in universes that recollapse, but it's still a useful thought experiment. If a civilization can control a collapsing universe, steering matter and energy as everything falls together, they might be able to arrange things so that the total amount of computation they can perform goes to infinity, slowing subjective time as physical time runs out. With effectively unbounded computation, they could, in principle, simulate every physically possible life that matches the earlier history, including every version of you that's consistent with your past history. That means, in that extreme limit, you don't just get one resurrection, you get countless versions, all waking up convinced they are the original, all tracing back to the same finite span of real history, all existing in different branches of an ultimate computational process. That's a very strong form of death as reset, but it depends on a very specific cosmology we do not see strong evidence for right now. In our actual best-fit lambda CDM universe, the future is not a collapse. It's a slow slide toward heat death. Dark energy drives expansion, galaxies drift apart, star formation fades, black holes slowly evaporate. Free energy gets harder and harder to access. But harder is not zero for a long time. There are billions to trillions of years ahead where stars still shine, matter still clumps, and energy gradients still exist. A long-lived civilization could adapt to that now. They could move to colder temperatures to reduce thermal noise and increase computational efficiency. They could slow their subjective time, doing fewer operations per second to stretch out their experiences. Each thought could take longer in physical time, but cost less energy, so the total number of thoughts before the universe becomes unusable could be huge. This strategy lets them perform more total computation for the same finite energy budget, and that computation can include simulations of past eras and past individuals. So even in a universe headed for heat death, there is a long window where resurrections are technically possible as part of big simulation projects, historical reconstructions, or even art and entertainment for entities with completely alien values. You are a potential data set, not because you're special, but because information about you is embedded in the universe's history, and a determined civilization could try to pull it out. Here's the key point though. In this scenario, death becomes a local event, not a final global verdict. Locally, your brain fails, your pattern is destroyed, you are gone from here. But globally, in the full cosmic story, that state can be approximated and rerun later. The universe doesn't automatically do that, it just leaves the option open. The reset button is not a law, it's a capability. Whether you actually get reset then depends on choices, not on raw physics. Some beings, unimaginably advanced, have to decide that resurrecting ancient minds is worth time, energy, and risk. They might care about history, ethics, curiosity, or they might not care at all. If they never choose to run that kind of project, the possibility stays theoretical, and you stay dead. That leads into a nasty question you can't dodge. If resets are possible in principle but expensive and selective in practice, what does it really mean that you find yourself alive right now in this one run with this particular set of conditions? Is that just random luck, or are there hidden selection effects that bias which minds get to exist and notice their own existence? And how often? If death is just a reset, you have a weird problem. Why are you in this particular run, right now, with this particular history, and not in one of the other possible runs where you lived longer, or woke up in some future resurrection project, or never died at all? Anthropic reasoning is the tool people use to even start that conversation. At its core, it's simple. You can only observe conditions that allow you to exist. You don't see a universe where stars never formed because then there'd be no heavy elements, no planets, no chemistry like you need for brains, and no one around to wonder about it. You also don't wake up in a reality where gravity is so strong that everything collapsed into black holes in the first second, or so weak that matter never clumped. Those universes might exist in some bigger multiverse picture, but you are filtered out of them automatically. That sounds trivial, but it has teeth. It means your observation, I find myself in a universe with these particular constants, these galaxies, this planet, this body, is not neutral. It's already heavily conditioned on you being here at all. When cosmologists talk about the probability of different universes or different histories, they have to fold in that selection effect. You are only sampling from the subset of scenarios that produce observers like you. That's the anthropic principle. Then comes the argument about how to treat yourself in that sample. One approach, the self-sampling assumption, treats you as if you're a random observer drawn from the set of all observers that exist, past, present, future, across all universes in some big ensemble. Under that rule, if there are far more observers in one kind of universe than another, you should expect to find yourself in the type with more observers. If resets are rare, you probably shouldn't expect to be in a reset run. If they're common, you should. Another approach, the self-indication assumption, says that the fact you exist at all is evidence that there are many observers out there. It kind of rewards universes that produce huge numbers of minds. Under that rule, scenarios with lots of simulations, lots of resurrections, lots of multiverse branches get extra weight because they create more observers to potentially be you. So your existence nudges the probabilities toward those rich scenarios. These are not just word games. Depending on which rule you use, you get different answers to questions like, how likely is it that most minds are simulated? Or how likely is a universe that runs lots of resets? If you assume self-sampling, you might say, I'm probably in a fairly typical, non-simulated run. If you assume self-indication, you might say, I'm probably in some high mind count scenario, like a multiverse full of simulations and resurrections. Physics doesn't tell you which anthropic rule is correct, so you are stuck with genuine ambiguity. Now zoom in from whole observers to individual instance of experience. Some people argue that the basic thing you should count is not observers, but observer moments. Each moment of conscious experience is one unit. Your life becomes a finite sequence of these moments, like frames in a video, maybe tens of trillions of them if you live many decades. In a huge space of possible experiences, that sequence is one specific path. In that framing, a reset is just a different sequence that shares the same prefix. If a future civilization reconstructs you up to the state you had at age 40, then lets your mind run forward in a different environment, that new life is a new string of observer moments, but the first part of that string is almost identical to the original. From your point of view, there's no way to tell which branch you're in, up to the point where they diverge, because your memories are the same. That makes the why this run question sharper. Your current evidence is, I am conscious now, with this set of memories and this sense of being midlife, or wherever you are. That one piece of evidence is compatible with many different realities. You could be the original biological version, you could be a simulated reconstruction that started from a saved brain scan, you could be a version in a universe that has already cycled a few times. You could even be one of many copies running in parallel. This also explains why you don't remember any previous resets. If resets exist, and each one starts from a brain state that only encodes your past up to a certain point, then by construction, you will never remember the act of dying, or the gap in between. You only remember the life that leads up to that state, and then you roll forward from there. That is exactly what you already see with anesthesia and coma. Your last memory is pre-shutdown. Then you jump to post-restart. The middle is blank. So your lack of past life memories is not strong evidence against resets. It's exactly what you'd expect if resets work by reinstantiating brain states that already contain a full history. Your only direct data point is that you are in one of those states right now, with some particular set of memories. That is consistent with a huge variety of realities where death is final, and with a huge variety where rests are sometimes followed by reruns. Now bring in the idea of measure, especially in multiverse or many worlds pictures. Not all branches or universes are equally large in the probability sense. Some have higher amplitude or more observers or more observer moments. Your subjective odds of finding yourself in a given situation are not just about whether that situation exists, but how heavily it's represented in the total structure. If branches where you survive are more numerous or occupy more measure than branches where you die early, then your subjective experience tends to track the longer-lived branches. That's where the phrase subjective immortality comes from. The idea that even if most branches of you die, there are always some where you keep going. So from the inside, you're more likely to feel like you just keep surviving against the odds. That's a controversial idea, and it depends on how you tie measure to where you find yourself. But even in a weaker form, it suggests that your experience can be biased toward longer runs and toward scenarios where something like a reset happens.
However, you don't get a free fantasy out of this. Anthropic reasoning also constrains reset theories. Any death as reset picture has to match simple, boring facts. You don't remember past lives, you don't notice blatant glitches in reality, you don't see physics randomly breaking to save individuals. You see a universe with clear, simple laws, where brains die and stay dead locally, where resurrections are not obviously happening in front of cameras. So any theory where you get reset all the time in ways that would leave obvious traces is ruled out by direct observation. The reset, if it happens, has to be rare, or distant, or subtle. It has to respect the existing physical rules. It has to produce worlds that look statistically like the one you're in now, not like a video game where players get resurrected every 5 minutes in the middle of a battlefield. That narrows down the space of possibilities. It leaves you with a few broad options. Maybe there are no resets at all and this really is your only run. Maybe there are resets, but they are extremely rare, far in the future or in distant regions. Maybe there are resets all over some bigger multiverse, but almost all of them are normal lives that feel just like this one. So from the inside, nothing looks special. And underneath all of that, there is still one big missing piece. You've been talking about patterns, information, measures, and observer moments. But to say what exactly resets, you need a clearer handle on what consciousness actually is in physical terms. What process has to restart for you to be present again, and how demanding that target really is. Before you talk about rebooting, you need to be clear about what is actually being rebooted. You say consciousness, self, me, but in physical terms, what is that process? One big camp is global workspace theory, GWT. In that view, your brain has a lot of specialized modules: vision, hearing, language, motor control, memory, emotion. They all work mostly on their own, unconsciously most of the time. Consciousness appears when some information becomes globally available. It gets broadcast into a central workspace that many modules can read from and write to. When something is in that workspace, you can report it, think about it, compare it to other things, and use it in flexible ways. So in GWT, most of your brain activity is not conscious at all. It's background processing. Only the subset that makes it into this global workspace forms your moment-to-moment experience. If you apply the reset idea here, what matters is not every tiny chemical detail, but the specific configuration where certain pieces of information are active and globally shared. A reset would mean recreating a brain state where the same kind of global broadcast is happening, with the same content, the same "I am this person in this situation with these memories right now" pattern in the workspace. Another camp is integrated information theory, IIT. It tries to give a number to how conscious a system is, called phi, written as capital Phi. The more integrated and differentiated the information in the system, the higher phi is. A system has high phi if its parts influence each other in a rich way, and if you cannot break it into independent subsystems without losing a lot of its causal power. Different specific structures with different internal cause and effect patterns correspond to different experiences. In IIT terms, your brain is conscious because it has a particular network structure and dynamics that produce a high phi with a very specific shape in cause-effect space. If you wanted to reset you under this theory, you would need to build another system with the same kind of integrated information structure, not just any high phi, but one that matches the original pattern closely, plus the same current state of activation. That combination would, in principle, produce the same qualitative experience. Then there's the view from recurrent neural dynamics, which is closer to how machine learning people think. A recurrent network, whether biological or artificial, doesn't just respond to inputs once, it feeds its own outputs back in. Over time, that lets it settle into stable patterns of activity called attractors. Each attractor is a state, or a set of states that the system tends to return to given similar inputs or starting points. Memories, concepts, and even moods can be thought of as attractors. Your sense of being a continuing self, a stable me running through different situations, might be an attractor in a huge recurrent network, your brain. The details of what you think and feel change, but the system keeps getting pulled back into a characteristic region of its state space, the U basin. In this frame, a reset would mean reinitializing the network inside that same basin with similar weight patterns and similar overall activity, then letting it run. The trajectory that unfolds from there would feel like your consciousness picking up. Some people take a more radical angle, panpsychism. They say that some form of experience is a basic property of matter, like charge or spin. Not human-level consciousness, but some primitive kind of what it is like attached to any physical system. In that view, consciousness is everywhere, but not everywhere organized into complex, unified subjects. What your brain does is integrate a huge amount of that basic experiential stuff into a coherent pattern, with structure and memory. If that's right, then a reset is not about turning consciousness on from zero, because there is always some kind of raw experience present in physical processes. The reset is about reassembling the right complexity and integration, about shaping the underlying field of experience into a very specific pattern that matches your past. So the system that forms you again doesn't create experience out of nothing. It redirects what was already there into your form. All these views push you toward a practical question. What are the minimal physical requirements for you? Does it have to be a human brain of this exact size, with this exact number of neurons? Or could a smaller brain or different substrate still host you? If you built a digital system that perfectly replicated the functional organization of your brain, same inputs, same internal connectivity, same update rules, would that system be conscious in the same way? Would it be you? Most theories that tie consciousness to structure and information say yes. You can also ask about speed. If you ran that system 10 times slower, with each thought taking 10 times longer in physical time, but internally having the same sequence of states, would it still be you? You wouldn't feel laggy because your experience of time is tied to the processing itself. If that's allowed, then the target for a reset is broad. Any physical system, biological or artificial, fast or slow, that realizes that same functional structure and informational states can in principle host you. The broader that target is, the more ways there are for cosmology or advanced technology to hit it. If you require exactly this arrangement of atoms in this exact brain, the chances of a natural reset are tiny. If you can exist in many different arrangements that implement the same pattern, the chances go up. A simulation, a brain replacement, a future alien computer all become candidate hosts. Even with all their differences, the mainstream scientific theories agree on a few key points. They all tie consciousness to specific, information-rich physical processes. None of them require an immortal, indivisible soul that floats free of physics. None of them give you a special particle that carries yourself from one place to another. They all say, in different language, what you are is a process with a certain structure and dynamics. That means if the process stops here, the local you is done. But it also means if an identical or functionally equivalent process starts somewhere else, there is no built-in law that says this cannot be you. From the inside, a restarted process with your memories and patterns would just feel like waking up, no matter where the hardware is. Brains, simulations, alien machines, they are all just different ways to implement the same kind of information flow. So now the problem is very clear. There's no special soul slot in physics to rescue you, but there is also no deep rule that blocks reboots of the pattern. The gate is not metaphysical, it's practical. Does the universe, with its limited energy and its one-way arrow of time, ever actually get around to rebuilding a system complex enough to run you again, especially as it heads into its own long, slow shutdown? Fast forward the clock, not thousands of years, not millions, but trillions. The familiar night sky is gone. No Milky Way, no bright band of stars, just cold, sparse light. If anyone is still around then, and if resets are possible at all, that's when they'd be trying every trick left. Start with how long stars actually live. Massive stars, the really bright blue ones, burn themselves out in a few million years.
fast, violent lives, lots of radiation, heavy element production, then supernova or collapse. Stars like the Sun sit in the middle. They live for around 10 billion years, 10 to the power of 10 years. They burn hydrogen slowly, stay stable for a long time, then swell into red giants and end up as white dwarfs, small, hot, dense cores. Red dwarfs are the real slow burners. These are low-mass stars, much dimmer than the Sun, but incredibly efficient. They can fuse hydrogen for up to about 10 trillion years, 10 to the power of 13 years. That's roughly 1,000 times the current age of the universe. So for a very long time, the universe will still have pockets of starlight, but eventually even those longest-lived stars use up their fuel, cool, and go dark. Once the last generation of stars fades, the universe enters what's called the degenerate era. You don't have bright, normal stars anymore. You have stellar remnants, white dwarfs, neutron stars, black holes, and drifting gas. The background light is faint and red. Everything keeps expanding and cooling. There's still structure, but it's old structure, slowly degrading. Those white dwarfs, the leftover cores of sun-like stars, don't stay white forever. They radiate away their heat over insanely long timescales, gradually cooling until they become black dwarfs, cold, dark objects, basically dead stars. If protons are unstable, which is still unconfirmed, then over around 10 to the power of 34 years or more, all matter made of protons, so basically all normal matter, will slowly decay into lighter particles. Positrons, photons, neutrinos. The universe becomes a thin fog of low-energy particles and radiation. Parallel to that, black holes move into center stage. In the far future, after most stars are gone and most matter has either been swallowed or decayed, the dominant structures in the universe are black holes. They are not perfectly black, though. They evaporate via Hawking radiation, but on absurd timescales. A black hole with the mass of the Sun takes around 10 to the power of 67 years to evaporate. Supermassive black holes with millions or billions of solar masses can last up to roughly 10 to the power of 100 years. As they evaporate, they leak out energy, and according to most modern views, they also encode information about what fell in extremely scrambled form. So even in this bleak, late-time universe, there is still some physical bookkeeping going on. Hawking radiation slowly releasing tiny bits of structure back into the cosmos, right up until the last black hole disappears and only weak, almost uniform radiation is left. Now imagine an advanced civilization surviving into these eras, or descendants of many civilizations merged into something bigger. Energy is scarce, but not zero. As long as there are stars, accretion disks, temperature differences, or black hole spin to exploit, you can extract usable work. The trick is to spend it slowly. One strategy they could use is to stretch subjective time, run their computation colder and slower, spread out their thinking so that 1 second of subjective experience takes millions of years of physical time. By doing that, they can get more total thoughts out of a fixed energy budget. Each operation costs less energy at lower temperatures, so by cooling and delaying, they can extend the number of computational steps before the universe becomes too uniform and too cold to support any further work. In that stretched out mode, they could have effectively billions or trillions of subjective years left to run simulations, reconstruct histories, and attempt resurrections as even the physical universe around them gets thinner and darker. But this strategy hits a hard wall. Thermodynamics doesn't let you cheat forever. In a true heat death, temperature differences vanish. Everything approaches the same tiny positive temperature, and there are no gradients left to extract free energy. No way to run engines, no way to flip bits in a controlled way, no way to maintain low entropy structures. Computation stops, and with it, minds. If lambda CDM is right, and there's no new physics to change the long-term picture, there is a finite total amount of computation that can ever be done. That means there's a hard cap on how much thinking any civilization, no matter how advanced, can squeeze out of the universe. No infinite resurrections, no endless simulations. At best, a colossal but finite number of runs, resets, and reconstructions, all packed into the eons before free energy hits effectively zero. After that, there is no hardware that can host a mind, and no process that can evolve one. So if resets are physically possible, the far arena is their natural arena. When stars are still around, you're busy not dying, building, expanding, surviving. When you get to the tail end, when the universe is old and mostly mapped, when the main challenges are boredom and energy management, that's when an ultra-advanced civilization might turn inward, using its galaxy-scale power to mine the past, reconstruct lost minds, try exotic computations, and treat resurrection as a side project of ultimate archival and exploration. From your point of view, that set the deadline. Not in human years, but in cosmic ones. If any version of you ever wakes up again in this universe as a digital reconstruction or a simulated mind, that has to happen before the last free energy sources fade and the last bits stop flipping. After that, the reset button, no matter how advanced the civilization, is physically gone. So zoom out. The whole universe has its own life cycle. Bright beginning, long middle, cold end. And the question of your reset is nested inside that arc. Somewhere between now and the final quiet, either reality does rebuild patterns like you, using the leftover energy to run a few more shows, or it doesn't, and this is the only run you ever get. And that brings you back from trillion-year timescales to something much closer to home. If a reset is possible at all, you still need to decide what even counts as you continuing, what kind of copy, merge, or reconstruction you would accept as yourself, and where you draw that line once the universe starts playing with your pattern. Before the universe ever brings you back, you have to answer a simpler, nastier question. What even counts as you? What does a reset have to get right for you to honestly say, yeah, that's still me? Start with the teleporter problem. A machine scans your entire body in insane detail, down to brain wiring and current activity. Then, this assembles you atom by atom and reassembles an exact copy on Mars. The copy walks out, talks like you, remembers your whole life, loves the same food, hates the same food. From the outside, it looks like teleportation worked. You step into a booth on Earth, you step out on Mars. Now twist it. What if the machine makes the copy first and then destroys the original? Is the copy still you? Most people's gut answer is probably yes, as long as I never see two of me. But if the machine glitches and for a few minutes both versions are alive, suddenly it feels wrong. Now the Mars version looks like a duplicate, not a continuation, even though it has the same structure and memories. That's exactly the tension in reset scenarios. If a future copy with your memories wakes up, is that genuinely you continuing, or is it just someone else who thinks they are you? Real brains give you more weirdness. Look at split brain patients. In some epilepsy surgeries, doctors cut the corpus callosum, the big bundle of fibers connecting the two hemispheres. After that, each hemisphere can process information semi-independently. In lab tests, one hand might do something the other hand can't explain. One side of the brain knows something the other side can't verbally report. Behavior can look like there are two partial centers of consciousness in the same skull. That suggests you is not an indivisible point. It's an emergent pattern that can, under some conditions, split into more than one stream. That already makes identity look more fluid than your intuition wants. If one brain can host two semi-independent you-like processes, then the idea of one you branching into two copies, or one you being reconstructed later, is less alien. The boundaries are already fuzzy in biology. Now try a slower thought experiment. Instead of teleporting you, imagine we replace your neurons one by one with artificial neurons. Each one is functionally identical. Same inputs, same outputs, same dynamics, same connections, but built from silicon or some other substrate. We do it gradually, over years. You never lose consciousness, your behavior stays the same, your memories and personality stay continuous. At what exact point do you stop being you? When 10% of your brain is artificial? 50%? 99%? There's no obvious cutoff, and most people, if they follow their own reasoning, end up saying, as long as consciousness and psychological continuity are preserved, it's still me, even if the material is different. Continuity of the running process seems to matter more than the specific atoms. That pushes you toward a very specific idea. Identity is about the continuity of the computation, not the stuff it runs on, and not the label on the box. That lines up with the reset picture. If some future process is continuous with your current mind in the right way, or at least starts from a state that perfectly matches your last state, then it has a good claim to be you again, even if the hardware or the environment is very different. Your everyday life already gives you weak versions of this. Every night, unless your sleep is totally wrecked, consciousness fades. You stop having a coherent narrative. During deep sleep, you experience nothing you can later recall. Then you wake up and your brain stitches together a feeling of same me, new day, without logging those hours of darkness. Under general anesthesia, it's even clearer. Your last memory might be the surgeon saying, "We're starting now." Then you wake up in recovery with no internal sense of time passing. From your perspective, both sleep and anesthesia are mini jumps. You hop over stretches of time with no awareness, then resume. You already accept this as normal. You don't wake up panicking that the original you died overnight and a copy with the same memories took over. You implicitly treat the resumed process as a continuation because it fits your memories and your sense of self. Cosmological or technological resets are just that same pattern of gap plus resume, stretched across bigger scales. So now you can ask a very direct question. What would you accept as a reset? If you woke up tomorrow in a different body, maybe a synthetic one, but with all your memories, your personality, your emotional reactions intact, and people around you confirm the history you remember, would you say the reset worked? Most people, after thinking past the initial shock, say yes, that would count, because the things they care about, memory, character, relationships, survived. That tells you what any cosmic or technological reset has to target. It doesn't need to reuse your atoms. It doesn't need to revive your original brain. It needs to reconstruct your psychological continuity, a mind that remembers being you, that feels like you, that reacts like you. If it can do that, you will almost certainly feel like you've continued, even if at some abstract level, philosophers can argue about whether the continuity is real or merely simulated. Now for the harsh reality check. Neuroscience and philosophy both point to the same annoying conclusion. There is no sharp, clean definition of the same person. Split brains, personality changes after brain damage, cases of extreme memory loss, all show you that identity can fracture, drift, or partially reboot. And yet, you still tend to talk as if there's a single you moving through all these changes. That ambiguity is not a bug here, it's the only reason the idea of death as a reset makes any sense. Physics can give you new runs of a pattern, but it can't tell you whether to call that pattern you again, or a new person with old data. That decision lives in the messy zone between language, intuition, and choice. If you decide that any exact or near-exact restart of the process counts as a continuation, then all the scenarios we've talked about, multiverse repeats, simulations, reconstructions, become live candidates for your reset. If you decide that only unbroken physical continuity of this one brain counts, then every one of those scenarios is demoted to copies that are not me, and death in this run is final. The physics doesn't change either way. It still allows or forbids the same patterns. The only thing that shifts is what you are willing to call a second chance. And with that on the table, you can finally step back and ask the thing we've been circling for all this time. Given everything physics does and doesn't allow, is it actually reasonable to treat death as a reset? Or is that just a story we tell to make oblivion easier to look at? Here's the uncomfortable answer. Physics does not promise you a reset, but it also does not cleanly rule it out. You're stuck in the middle, between one run only and maybe there's a sequel. Start with the part that is solid. Consciousness, as far as we can tell, is tied to physical processes in the brain, not to a separate soul substance. When blood flow stops, neurons lose fuel. The activity collapses. Structure starts to break. After a few minutes at normal body temperature, the fine wiring that holds your memories and personality begins to degrade. Once that microarchitecture is gone, this particular run of you is over. There's no known way to bring this brain back to the same state. At the same time, we have strong hints that the universe, at a fundamental level, keeps track of information. Black hole physics, quantum theory, and the way our equations behave all push in the same direction. Information is not truly destroyed. It gets scrambled, spread, encoded in ways we cannot access but not erased from the global book. And when you combine that with cosmic scales, trillions of years, 10 to the power of 26 meters and beyond, you get absurd amounts of room and time for patterns to recur, including patterns that look like minds. On top of that, you have technology as a wildcard. If advanced civilizations exist, the kind that sit at Type 2 or Type 3 on the Kardashev scale, harnessing star or galaxy-level power, then in principle, they could reconstruct or simulate past minds, including you, using cosmic forensics and huge computers. They could approximate the brain states of long-dead humans and run them as digital processes. You would wake up in their machines convinced you've been brought back. Now for the things that are plausible but unproven. If space is truly infinite, or if the universe cycles through endless big bangs or big crunches or bounces, then the statistics get brutal. A finite pattern, like the one that defines your brain, is expected to repeat somewhere, sometime. Not just once, but many times. The Level 1 multiverse and cyclic cosmologies lean in that direction. They don't guarantee you will like the result, but they make repeats very hard to avoid. Quantum theories, like many worlds, add another layer. Every quantum event branches reality into multiple outcomes, so there's a vast branching forest of yous, some dying early, some living longer, some making different decisions. As long as there are branches where you keep going, there are versions of you that never hit a hard stop. And if you follow the more speculative lines, some people argue that your subjective experience tends to track those surviving branches more often. Then there are simulations and resurrection projects. These are not forced by the laws, but they are not forbidden either. A simulated universe that runs ancestor models, a future alien archive that reconstructs every life it can infer from the fossil and radiation record, these fit comfortably within what physics allows. They just need extreme engineering and extreme motivation. And right now, we have zero direct evidence that anyone is actually doing this. On the other side, there are things that are almost certainly wrong. A magical reset that breaks conservation of energy, or throws away quantum mechanics, or introduces a new soul particle that ignores a standard model. That picture collides with pretty much all of modern physics. You don't get a special exemption from thermodynamics and quantum theory just because the topic is scary. Every time we've looked closely, the brain has behaved like very complex but ordinary matter. Any reset story that says you just pop back because that feels nice without a physical mechanism or a place in the equations is not a theory. It's a wish. If something is going to restart your mind, it has to use the same basic machinery as everything else. Space-time, fields, particles, information flow, computation. Otherwise, you're just stapling your hopes on top of a universe that doesn't care. So what do you actually do with that, from a scientific, sane point of view? The rational bet is simple. You live as if this run is the only one you can count on, because that is the only thing you directly know you have. Your current stream of experience, tied to this body, on this planet, in this century, is guaranteed real. Everything else is layers of maybe. If a reset happens through some combination of multiverse repetition, future civilizations reconstructing you, or unknown physics that still fits inside our laws, that is a bonus level, not a guaranteed sequel. You don't plan your life around winning the cosmic lottery. You don't treat "I might be resurrected in a trillion years" as a reason to waste the next 10 minutes. You treat the possibility as interesting, not as a safety net. The honest conclusion is physics gives you possibility, not promise. Your mind is a physical process. The universe is big. Information is sticky. Patterns can recur. But none of that adds up to a contract that says you will definitely wake up again somewhere. You have to act under uncertainty, knowing that total oblivion after this run is very much on the table. So, how do you wrap that for someone watching a video like this? You tell them straight. You are a roughly 20-watt pattern of information running on about 1.3 to 1.4 kilograms of tissue, built from atoms forged in stars billions of years ago, in a universe that is 13.8 billion years old, and maybe infinite in extent. Your thoughts right now are a local, temporary computation on that ancient stardust. When you die, that computation stops, locally, permanently, as far as any medical device, any brain scan, any physics experiment can see. But on very large scales, in space, time, and possibility, there is room for processes that look like you to start again. Somewhere, somewhen, in another brain, in a simulation, in a distant patch of an endless cosmos. If that ever happens, from the inside, it would not feel like a clone woke up. It would feel like you opened your eyes after a gap you never felt. So maybe death is not a guaranteed reset, not a button you can rely on, but it also might not be a concrete wall. It might be more like a local stop sign with a long, dark highway beyond it, where very rarely reality decides to run the experiment again. And the only question left hanging as the credits roll on this run is the one the universe never answers directly. Do you want to go again? This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. If you enjoyed the video, consider subscribing to the channel and like the video.